So now let's talk about the Netflix recommendation system. So the idea is that we have some predictor, just this big black box right now, okay? And the predictor takes some input, which is what we know, and it generates an output, which are the predictions. And there was predictions for what we think that you'd like. All right, so the predictor is going to say, oh, this movie, I think you're going to rate it as a 4 stars or something like that. So for Netflix, the input to the recommendation system is each rating. Now, the ratings are composed of a few different metrics which are useful to us, a few different data points. First one is the user ID. So who is the person? Is this Bob? Is this Alice, Charlie, whoever? Then the movie title. All right, so it's is this Good Will Hunting? Is this A Beautiful Mind? Is this Lion King? Whatever movie it is. What are the number of stars? So how many star ratings did you give it, right? So it has who you are, it has the title of the movie, and it has the rating that you just gave in terms of 1 to 5. You either rated 1, 2, 3, 4, or 5. And also the date of a rating is important too, and Netflix does use that, but we're not going to look at that here, but date of rating is also an input there. And the output is first a set of predicted ratings. Okay, so we don't know, you haven't watched this movie, but we're predicting you'd rate it as a 4 star or a 3.8 stars or something like that. It doesn't have to be an integer number, even though when you have the input, it's always integers. The output won't always be an integer. The reason it won't always be an integer is because you won't actually see those predicted ratings. As the user, what you see is the recommendation. So this is what's actually transparent the user. It's the recommendation. We think you should watch movie X, movie Y. You watched Good Will Hunting, we think you should watch A Beautiful Mind, or something along those sorts. So they don't show you the predicted ratings, then they show you the recommendations. So this is not shown to you, this is shown to you. And this is just showing it graphically though. And we do actually need to deal more so with the predicted ratings here. We can't deal with the recommendations because we have to evaluate the predictor for accuracy. And we'll talk about that in a second. Let's first just look at this table just to get an idea. So on this side, we have the input to the system. It's we give it in a tabular form. So it's just shown as a table. Down the rows are users, and across the columns are movies, right? So this user and this movie, you can see this has a question mark here, something that we don't know. You can just read. Then we'll say maybe this user, and what about this movie, right? So you can come over through and see that he rated this movie a 4 star. So on. It's just a concise way of depicting that input. And the question marks, again, denote the ones that we don't know. So we don't know what this user rated this movie. We don't know what this user rated this movie because it hasn't been inputted yet. It's not that it's there and we just don't know it, but we don't know what this user thinks of this movie because he hasn't watched it yet, for instance. Then and you make a prediction, and the output again is a user movie table. We can look at it as such at least, but it's just the predictions, right? So the predicted ratings. We predict 3.1 for this movie. We predict 3.2 for this one that hasn't been watched. 2.8, 4.5, 3.8, 3.2, and then we can use this data to say then for each user what we think the person should watch. So, well, for this user up here, for instance, we see there's 2 movies. There's 3.2 rating on this one, 3.8 rating. So we would say, okay, well, you should watch this movie, for instance. Okay. Then this user down here, 2.8, 3.2, we'd say, okay, well, you should watch this movie, for instance. Then for the first and the last one, it's trivial because there's no other movies. But in general, there's just a ton of movies and a ton of users. And this, again, is just a really small depiction of the idea. And we don't have to recommend just one movie. We could recommend multiple ones. We could recommend the top 10 movies, say, that the person hasn't watched yet. And then we need to actually evaluate this system, okay? And again, we can't evaluate it in terms of the actual recommendation because then we have to ask people, what they think of the recommendation. Instead, we try to have a quantifiable metric. And the metric that we use is called the root mean squared error, RMSE. And it's a mouthful. We'll go through how you actually compute it, and we'll walk through it step by step. But it's just basically an error metric. The lower, the better. It's the difference, the error and the prediction versus the actual values, right? So really what we'll end up doing is we will withhold some of the values that we actually know. Like, for instance, this 5 right here, we might hide that from our system. We might hide this 3 from our system and this 3 from our system. And then run through with the values that we're assuming we know, and then test and see how close the values we hid are from what they really are. And then we can therefore make an inference if that's a really low RMSE. If it's really good at predicting a few of the values, then for the ones that we actually don't know, we would assume that it's probably a pretty good system, right? Because we're not using any of the values. So it's kind of the same idea. Is that we don't know them. The recommender system wouldn't know about this value, or this value. And so then we could take this, this, and this, and looking at this table right here, we'd predict values here, here, and here, and then to the RMSE and see how good the RMSE is.